Okay, sample problem 18.1, our first entropy problem. Determine the change in entropy for 1.0 moles of an ideal gas originally confined to 1/2 of a 5.0 liter container when the gas is allowed to expand to fill the entire container at constant temperature. So one thing to point out is when you hear or when you read that language, constant temperature, that is what we call an isothermal process, okay? So what's happening is the gas is originally contained in 1/2 of a 5-liter container, okay? So the volume of this container is 5 liters. Originally, the gas is confined to 1/2 of that. Now, what's 1/2 of 5 liters? 1/2 of 5 liters is 2.5 liters. So our initial volume is 2.5 liters. It then goes what's called isothermal expansion. Okay. So now the volume of the gas is 5 liters. Okay. The final is 5 liters. For isothermal expansion of a gas, the change in entropy, delta S, of that gas, which we'll call a system, is equal to the number of moles of the gas times the universal gas constant R times the natural log of the final volume over the initial volume. Okay, very simple equation. So that would be equal, we have 1.0 moles. When we're doing energy calculations or calculations involving energy, the value of R that we would use is 8.314 joules per kmol. And then that would be multiplied by the natural log of 5.0 divided by 2.5. I'll leave the units out because they'll divide out anyways, okay? Now, 5.0 divided by 2.5 is 2. So very simple calculation. 1.0 times 8.314 times the natural log of 2, which is 0.693 approximately. And you get 5.76. That's a little bit too many sig figs, so we'll round it to 5.8. The units, what happens is the moles cancel, and you get the units of entropy, which are typically in joules per Kelvin. This is positive. Delta S of the system is greater than 0. And that's what we would expect for an isothermal expansion of a gas. The amount of internal entropy that this gas has is less when it's in a smaller volume. It has more freedom in the larger volume. So the change in entropy, delta S system, is the entropy in the final state minus the entropy in the initial state, SF minus S initial. We would expect that to be greater than 0.